Hi guys, welcome to my channel and welcome to SSCE Mathematics from zero to hero. Today we'll be continuing from where we stop and I will be taking you through modular arithmetic today. Modular arithmetic. Modular arithmetic is also called a clock arithmetic. When we say a clock arithmetic is an arithmetic in form of a cycle. So, and don't forget, a cycle is something that changes. Take for example, when you have your work clock like this, something of this nature, you will notice that the hands that count the minute, so you will notice that when the hands moves from 12 and it goes clockwise like this, it will also ends at 12 and start again. You understand now? So when you have this kind of movement, so we call it, we say that it has completed a cycle at 12. So because when it stops at 12, it's going to start maybe at 1 again. So this type of arithmetic, when you have an arithmetic in this form, so it is known as a modular arithmetic. So that is a system of arithmetic that wrap up around after they reach a certain number. So after they reach a certain number. Modular arithmetic is also a special system of arithmetic that involves only integer. It involves only integer. Don't forget, we have system of numbers. Don't forget, we have natural number. When we say natural number, they are the set of what? Counting numbers. They are those numbers we were exposed to when we were in primary school. So likewise, we have integers. This number is denoted by n. So likewise, we have integer. So what are integers? So they are the set of positive number, so negative number and zero. So when you have this kind of number, so they are said to be integer. So likewise, we have a rational number. So rational number, a number of the form P divided by Q. So where Q is a number not equal to 0. So in essence, when you are working in a modular arithmetic is a system of number that involves only integer. So in essence, you cannot get a rational number. So you cannot get a rational number. What you can only have is what? Is an integer. For example, so let's say if I have 4 as an integer, or you have any integer. So if you divide an integer by 4, any integer by 4, just think of it. So you will notice that the possible remainder you can have is either 0, 1, 2, and 3. Can you have 4 as a remainder? That is not possible. So this is what I'm trying to say. For example, if you take 12 and you divide 12 by 4, you know you are going to have 3 divided by 0. So just take any integers. So when you divide it by 4, so the possible remainder you can have is what? Is 0, 1, 2, and 3. So when all the integers now, the set of all integer, when it's now reduced to a set of numbers containing 0, 1, 2, 3, you understand now? Then we are said to be working in modulo 4. So we are said to be working in a modulo 4 or with modulo 4. So you can as well shorten it as mod 4. Are you getting that now? So, and don't forget, modular is what? Is the plural form of modulo. It is the plural form of modulo. Don't forget I said the other time that when you are dividing integers by 4, the possible reminders you can have are 0, 1, 2, 3. You understand now? And I said if you have this set of numbers, so you are set to be working in modulo 4, right? So all these sets 0, 1, 2, and 3, they are known as what? As residues. So they are called residues. So in essence, if I'm working in modulo 5, then I'm going to have which residues? So my residues will be 0, 1, 2, 3, and 4. Likewise, we are working in modulo 6. So you are going to have residues from 0 up to 5. You must not have 5. So likewise, we are in general, if you are working in modulo n, then residue will contain set of number from 0, 1, 2 up to h, up to n minus 1. So if you look at it critically, you will observe that this number is more or less base system. Don't forget when I taught you, so number base, I said when you are working in number base system, the principle is that when you are working in base 5, for example, then all number you must have must not be 5 or number greater than the 5. You can either have 0, 1 up to what? Up to 4. So this is the same for modulo. But the difference between modulo and when you are working in the number based system is that when you are working in the modular arithmetic, so we only work with what? With remainder, and we just forget about the multiple. You understand now? So for example, let's say if you are dividing 15 by 4, and I'm working in if I'm working in modulo 4, my 15 will be what? 15 divided by 4. And you say how many 4 are you going to see in 15? That's how many? That's 3, remainder what? Remainder 3. So then 15 is equivalent or congruent to 3 modulo 4. You will notice that we only write the what? We only write the remainder, and we didn't take into account the multiple. But that could not be possible when you are working on the number based system. For example, if you are working on a number based system, know for sure that you cannot have 1 5 base 4. Can you have that? Because the principle on working on number base is that when you are working in a particular base, then this set of number you must have must contains of number between 0 and that number minus h minus 1. So, and you notice that 5 here is greater than what? Is greater than 4. You understand that? You see the difference now? So these are the differences between what? I mean, modular arithmetic and the number based system again. So when you say modular arithmetic, it is a set of number that wrap around after they reach a certain number. Let me give you an example to back it up. For example, I have simplify the following. Number 1, I have 81 mod 5. Number 2, I have 501 mod 6. Don't forget I told you that we are said to be working in a particular modulo, let's say modulo 4, or with modulo 4, when all the integer reduced to what? So 0, 1, 2, 3. You understand that? That is, you can only have this remainder. So for example, for this first question here, I'm asked to simplify 81 in modulo 5. So don't forget we are working in modulo 5, and all my residues will be what? Be a set of number from 0, 1 up to h, up to 4. You must not have 5 or number greater than h or number greater than 5. So the moment you reach 4, then it will start from 0 again. That's why I call it a cycle arithmetic. So for 81 here, to express it or to simplify it in modulo 5, what you are going to do is to what? Is to divide 81 by 5. Then you now see how many 5 are you going to see in 81. 5 in 81, 5 in 8, that's 1, remainder 3. So 5 in 31 is 6, remainder 1. So then don't forget I told you you are going to write only the remainder. Then you can conclude adequately that your 81 is congruent or equivalent to 1 mod 5. You have to put the modulo you are working. So can you see it is very simple? We don't write the multiple, you only write the h, you only write the remainder. You understand now? So you know I wrote that our 81 now is what? So this sign is known as congruent to or equivalent to what? So to 1 in what? In modulo 5. So let's do the second example. We follow the same thing. So we have 501 modulo 6. Don't forget we are working in modulo 6. So and the possible residues, possible remainder we must have in this particular modulo which is 6 must be number between 0 and what? 0 and 5. So you must not have what? Number greater than 5. So if you, once you get to 5, then you have to what? You have to start again. It is a residue. And to simplify this, don't forget you are going to divide by the modulo. How many 6 are you going to see in 50? So that is what? 8, remainder 2. So 6 is 21. I think that is 3, right? Remainder 3. So 6, remainder 3. So don't forget we are working in a modular arithmetic and we are only concerned with what? With the remainder. Then you can say your 501 is congruent to what? To 3 under modulo what? Under modulo 6. Under modulo 6. So that's that. So then we can conclude that. So for an equivalent modulo now, so we say a set of modulo are equivalent or congruent. So if you have two integers, so and both two integers have the same set of what? Set of remainder. So let me give you an example to back it up again. If I have a question that says, example, show that 82 and 37 modulo 9 is congruent or what? Or equivalent. So don't forget I said two integers are said to be equivalent if they have the same remainder. So that is, you have the same residue for them after dividing by the modulo under operation. So for you to do this, you take the number one by one, 82. You know what we have to do is that when you simplify 82 in modulo 9 and 37 in modulo 9, then you must have what? The same remainder. Let us do that. So you have that 82 divided by 9, that is 9 remainder 1. So likewise for 37, that will be 37 divided by 9. So that is what? That is 6 remainder 1. Then you can say here that your 82 is what? Is congruent to 1 modulo 9, and 37 is also congruent to 1 in mod 9. What do you observe? You will notice that this one, which is my remainder, is also the same thing as remainder when I simplify 37 under what? Under modulo 9. Then you can conclude adequately that 82 and 37 are equivalent or congruent in modulo 9. But before I conclude this, what do you observe? You will notice that when I have this 82, these two integers that are equivalent, that is the 82 and 37. When you subtract the two numbers from each other, so you know this will give me what? 45. So you notice that I have 45, which is also a what? A multiple of 9. You understand now? So in general, so when you have two integers, x and y, And you said these two integers S and Y, when you say they are a congruent modulo under what? Let's say under modulo N. You understand now? So then their difference, when you now subtract it, S minus Y, so will be what? So will be a multiple of N. So will be multiple of N. So where N is what? Is the modulo you are operating. So for example, now you know we are operating modulo 9, so our N will be 9. So that is your S minus Y will be what? N M. So or you say M multiplied by N. So where your M is the multiple of what? So of the, and N is the modulo. So that is the multiple of the modulo you are operating. Like we have here, 82 minus 37 is equal to 45. So which you can rewrite as what? 5 multiplied by 9. So don't forget that. So this is where I'm going to stop. In the next video, I'm going to start with basic operation involving modulo. Don't forget, if you like this, my explanation, don't forget to subscribe, like and share with your colleagues. Thank you so much for listening. See you in the next video.